Hello, everyone. Today we're talking about cardinality and ordinality. So the idea here is to tell the difference between the two and how they contribute into the learning of mathematics, especially for the foundation phase learners. So in terms of understanding this, you will understand that it's easier to move on from cardinality to ordinality, but we're going to look at it in terms of how foundation phase learners learn it. So cardinality refers to the number of elements in a set. It answers the question, how many? You also remember counting number principles. So for example, if I have 2468, the cardinality of S here, it's going to be 4 because there are 4 elements in a set. So as I said earlier, it answered the question, how many? So in early childhood education, when children count objects, like 5 apples, for example, they are developing an understanding of cardinal numbers. Hence, we say it answered the question, how many? And that's what cardinality is all about. And then on the other hand, ordinality refers to the position or order of elements in a sequence. It answers the question, in what order? So, for example, in a race, if the runner finishes first, or another finishes second, another finishes third, these ordinal numbers, which is the first, second, and third, right, are the ordinal numbers. They are used to describe the order, but not necessarily indicate the quantity. It tells you where the position is. Okay. This can also be, for example, if there were 5 people and I said, no, the third one from the left. That's what ordinality is all about. Okay. So the key difference is that the other one tells us how many, the other one tells us the position. Okay. So in summary, cardinal numbers tell us how many, while the ordinal numbers tell us in what order they appear. Because the concept of both concepts are essential in understanding number sense, counting, and mathematical reasoning, because they go hand in glove. Okay. So children need to learn both meanings of the number, which is the cardinal, size of the set, and also the ordinal, which is the sequence of the numbers. So they need to use and move between different representation of numbers in both pathways, because the other one uses the other one in terms of how they work. So they are interdependent. So both pathways, children choose or repeat a unit. Okay. So when children count how many discrete objects there are in a set, they must first decide what should be in a set. Okay. At first, this is about classifying which objects belong to the set, which objects belong to the set of children. So if, for example, I give you 5 children here looking, facing each other or facing us, and then I says, how many? So by saying how many, I need to know what exactly are we counting? Are we counting the number of things, or are we counting the number of eyes? But what we are counting there will determine what we are looking at. For example, and that will determine our cardinality. If, for example, I said, no, we're counting the number of heads, or the number of eyes, or the number of fingers, they have all 5 of them. So they choose what object to count, which is sometimes, or most of it is not that they choose, but the teacher decide so that they can count that particular instance or that particular item. So also when measuring, when children measure a continuous quantity, they must first decide what attribute should be measured. Okay. So for example, are we measuring the length? So there are different things that can be measured. And this is part of the ordinality, because ordinality is when you look at the position and what must be measured. Okay. So there are 2 main routes on developing number sense. One is the counting pathway, and there's also a measurement pathway. The counting pathway is where the starting point is discrete quantities. And then the measurement pathway is where the starting point is the continuous quantity. So to understand this, you will understand that perhaps you might think of measurements only in terms of standard units, like when you talk about the length and you talk about the meters, centimeters, milliliters, and so on. And also when you talk about the measurement in terms of mass, milligram, and kilogram, these are just standard units which you have come to know over time. But very, very young children, can measure before they know all these standard units. So, for example, a child can tell if they have an older sister and that the older sister is taller than them. Okay? Uh, they can lift a bag or a shopping bag and choose to carry the lightest bag because they can tell that this one is lighter than the other one. They can race to see who will go home first. All these, you can see their measurement, compare the heights. They ask who is taller. Although they won't use the exact measurements, but they will tell, okay, because of the difference in length, they can tell who is taller. They can see who can hold their breath for the longest. Okay? So part of this is part of measurement, whereby I'm saying that learners can describe these particular attributes without learning the unit of measurements. Okay, so now this discrete, so there are discrete and continuous attributes, which also form part of the cardinality. So what are the discrete? Discrete means that you can separate or move each object, and you can also see and count each object from the collection. Like for example, here, I can count the number of bananas here. That there are 6 bananas and they can be separated one by one and counted one at a time. Okay, so discrete objects and events. So discrete, the example of discrete objects would be people, fingers, apples, and so on. Then the discrete events. Events is something that is happening and it's continuing. Like if I'm saying jump, I can count the number of jumps. Can you see? Those are discrete because they can be separated. He jumped 5 times, or he clapped 30 times. Okay? Or breathe in and out and said, oh, he breathes 5 times. Okay, the chime in a bell, the clock ticking, all those are events that are happening, right? So, and they can be discrete. So children count the number of each different types of animals and draw the same number of dots. And each dot represents the discrete objects. Now, if you look at this, this is what I was referring here as what? Discrete objects. Okay. This was taken from the GDE book. And from the GDE book, you can see that we just give a picture. And remember, as I was saying earlier, that they need to first choose what they are counting. So I can say, count the number of ducks, right? Or count the number of chickens. Okay? Then you count those things based on what you are seeing there. And those are your discrete objects. Okay. Then you have the continuous attributes. So continuous means unbroken or without interruption, like water. Water, you can, it just keeps flowing. You can't count waters, right? So water is continuous. Something this is liquid or sand, things like those. So examples of continuous quantities are extend at the area of the field, right? The length of a stick. You see, although we can count the number of sticks, but one stick, when we look at its length, then it is continuous. Because why? It is not broken, it's one thing. Okay, and this is where we talk about the concept of the measurement as well. Okay, so the question now is, can discrete attributes become continuous? Yes, they can. If you look at oranges, I can count how many oranges there are. But if I take the oranges and blend them, I will get an orange juice. And the orange juice now is now liquid and is now continuous. Can you see? And that's what we say what? The discrete objects can be made continuous. And also, continuous objects can also be made discrete. Like if you look at water, water is continuous. But if I add the water into the glasses, then I can count the number of glasses. And now the number of glasses, whereby I'm counting the number of glasses of water, that is discrete. Okay. So basically, what I'm saying here is that continuous attributes can become discrete when you introduce the unit of measurement. And in this case, the glasses is the unit of measurement, right? So understanding this, you can see that if you're looking at the difference between the continuous quantities and the discrete quantities, you have the counting pathways and the measurement pathways. That with continuous, we usually measure. And then with discrete, we are always counting. And you always have the counting unit with the discrete, which is either we count in ones or in twos and fives. Whereas there, with the continuous quantities, we need to find the measurement that we are using. Either we introduce the unit of measurement whereby it can be millimeters so that we can count how many meters are there or how many millimeters are there. Okay. Then tomatoes on a plate, right? Tomatoes on a plate, you can see that I can count how many tomatoes are there. And those are discrete objects. And then we look at the continuous attributes there. In terms of metaphor, is if you're looking at the number line or the fence, are we counting the poles or we counting the distance between the poles? And if you're looking at the distance between the poles, then that would be your continuous quantities. In terms of as learners move on, we normally then introduce the number pictures, like so that they can start counting differently, like counting tens and so on, or counting fives and counting ones. But part of it is the representation of the discrete quantities, whereby we start merging them. And this is the same thing when you realize what I was talking about when I said things can be combined and discrete can be made to be continuous. Okay. And this makes life easier for you to understand how the two are different. So continuous quantities can be measured using the measurement unit, as I said earlier, and the amount of time, the amount of ground and amount of water, the volume and mass are continuous. But we can count time, we can count distance and water. All these things are continuous because we can't count them. But we need to measure using an agreed unit as these are continuous extents. As I said, for example, if, for example, I give you a bag full of sand, right? You can't count the bag full of sand, right? But if I want it to be discrete, I must decide that, okay, we're going to count in kilos. So I come with buckets of 1 kilo each, right? Then I can count how many kilos are there, how many buckets are there in that particular bag of sand. And that's what I can count. So time is continuous. To hold your breath for a unit of 1 minute, you must agree when to start. Then you time for 1 minute to get to the end of the minute, right? And you can see that time is continuous. But if I'm saying now we're counting it, it's when we're introducing, we're going to count it now in minutes. How many minutes were there? And remember, when I was talking about the cardinality, it's all about how many. And you're doing the how many in a space whereby it is a continuous. Then you have the length, right? To run in a race, you must agree where to start and where to end. And there we can count how many meters did the person cover. Okay, if they cover 100 meters, and that becomes a standard unit. So we can have a collection of 800 people at an athletic event. People are discrete objects, but we can't have a collection of 800 meters. Okay, so length is continuous quantity. However, we can introduce a unit of length which can be used to measure the length, right? Even though we know, so by means of measuring, we measure something, and then when we get the answer, it will be in a form of cardinality. Okay. Look at the concept of volume. Like when you talk about water, water is continuous, but when we put water in a JoJo tank, right, that is still continuous. But if we start bringing in buckets, then we can count the number of buckets. Okay. The mass. Mass is how heavy or how light something is. And to measure how heavy something is, we need to compare its mass to something else, right? And that helps you to understand the concept of measurements. And bringing the unit of measurement is either we can measure it in kilogram or in milligrams, but either way, that becomes the unit of measurements. So in order to understand this concept, you need to decide what to measure, decide where to start, decide on a unit to measure, and measure the attributes by comparing to the units. Okay, and this is how normally you teach measurements to the foundation phase learners. Okay, and it makes it easier. Say the children agree to compare the length of the stick, right? If you look at what I have there, so children must position both sticks at the same starting point, and they must be straight. That way they can see which one is longer, and that is measurement without bringing in the unit of measurement. Same thing here. There must not be a gap. If you're measuring, you can use the continuous objects by means of saying, okay, we're going to use hands or the palm of the hands as the unit of measurement. And by so doing, you can then count the number of hands and be able to tell which one is longer in terms of how many hands that one can cover. Okay, so as there are different attributes which we measure, how they learn to measure differs, but the same measurement principle apply. Later, the measurement trajectory is extended as they start to learn about the system of international SI units of measurement. So when we start in foundation phase, we don't just bring in the millimeters and the meters. We start it by informal measurement, which is the one I'm explaining here, whereby comparing in terms of the size and the length, comparing which one is taller and which one is smaller, okay? Or which one is heavier and which one is lighter. So in these cases, they are not discrete objects that forms a collection. They are objects of an event which are being compared. When comparing continuous objects, we apply the measurements of learning trajectory. And this helps you to understand this particular concept. So when you, for example, as I said earlier, in these particular pictures, what are we measuring here? Which is the attributes. We're measuring the distance, who will arrive first, right? Or we're measuring time. So in this particular instance, we're measuring time by the one who arrived first is the one who win, for example. Where do we start? Which is what is being measured. We're measuring that who will arrive first if they run from here to there. And the concept is the issue of measure the attributes by comparing the unit. What are we comparing? The speed, the time. The one who finished with the less time is the one who wins. Okay. And this is how you normally look at the two. Okay, guys. I thank you. Okay. If you have any question, send me an email and I'll be able to assist you. Thank you so much.